A very wonderful morning to one and all. This is Kavin from Kongunadu College of Engineering and Technology, working as an assistant professor in mechanical engineering. Today we can see about the topic in fluid mechanics and machinery. The topic we discussed is dimensional analysis. What is meant by dimension? Dimension is a numerical parameter for the properties of an material. In this, the dimension is used to measurements or the prototype when been converted into the model. The dimensions are much used. So first we can see about why the dimensional analysis is important. Many problems in fluid mechanics rely on the experimental data. It is impractical to perform cost or time experimental study for every variation of original problem. Testing large structure is impossible. So model is used, but how do we know make sure it represents the prototype? The prototype is a model of a very large structure. If a road can be constructed for a 3 kilometers, the prototype is made for just 3 meters or 3 centimeters like that, but it represents all the data in the structure like that. A prototype even for a large structure like dams, large construction, first of all they can made a prototype and then they can be analyzed and then they can start their work. Dimensional analysis helps in reducing the size of the problem. The large type of problem has been measured by reducing size of the problem by using dimensional analysis. Suppose we are studying the pressure drop per unit length of a pipe in a smooth, long, circular, horizontal pipe, assuming steady and incompressible flow. Pressure drop delta P1 is expected to depend on diameter D, unit is meter, velocity V, unit is meter per second, density rho, unit is kilogram per meter cube, viscosity mu, Newton second per meter square. Therefore, delta P1 is equal to function of diameter, velocity, density and viscosity. We should design an experimental study to understand and came up with the nature of the above relation. Since we have 5 different variables with different units and different dimensions. Let's keep 3 fixed and see the effect of fourth one on delta P1. Therefore, here the diameter has been increased by reducing the delta values. We can see in the graph when the delta values has been reduced simultaneously, therefore the diameter value has been increased. We can see next for velocity, here it is directly in proportional to the previous values. Here the delta value has been also increased, but the velocity of the flow has been increased. We can see in the graph, but here the constant increase has been seen in this graph. In the before graph we can see sudden reduction and the sudden increment, but here the constant increment and constant decrease has been seen. How many experiments you have to do you forecast any problem in this problem? Let's see in the next PDF. Buckingham Pi theorem, it is one of the important theorem for the dimensional analysis for the iteration or reducing of the constant variables and dependent variables. The original values can be replaced by less number of non-dimensional terms like pi terms. In this Buckingham Pi theorem, according to the variables, the iteration has been done. So the number of pi terms has been first find out by the number of original values to the number of basic. We have to know that which are all the basic values and which are all the original values from the given experiments and then solve the problem. Basic units are all the variables are expressed in 3 basic units. First one is length L, unit is meter. Next one is time T, unit is seconds. Next one is mass, unit is Newton or kilogram. Example, velocity, the unit of velocity is meter per second. The dimensional analysis is L by T. Density rho, unit is kilogram per meter cube, but the dimensional analysis is M by L cube. Viscosity is mu, Newton second per meter square. Their unit is M by LT. Pressure P, force by area. Their unit is meter per LT square. Back to our problem. Number of original value is 5 and number of basic value is 3. Therefore, number of pi term is 5 minus 2. We will replace 5 variables by 2 terms, which is much easier to deal with. How do we develop the 5 terms, which we can see in the next paragraph. Exponent method has been used. List the original values involved: delta PL, diameter, velocity, density, viscosity. Express the original values of the Gaussian. The original value of the delta PL is m by L square into T square. The original value of diameter is L. The original value of V is velocity, L by T. The original is density is m by L cube. The original is viscosity is m by Lt. Determine the number of 5 times is equal to 5 times is equal to number of original value into the number of basic units. Here number of basic unit is 2, number of 5 times is 5, so therefore 5 minus 3 is equal to 2 has been found out. Experiment method is continued. First, select the repeating variables from original values. Number of basic unit here is 3, excluding the primary variable del PL. We can see about the number of the basic units: diameter, velocity and density. From the 5 terms as shown below, phi 1 is equal to delta PL into dA V power B rho power C. Delta pi 2 is viscosity into d power D V power E and rho power F. Next step, we can find out, determine the unknown components by using the fact that each phi term is dimensionless. So for phi 1, delta PL d power A V power B rho power C, the units of phi term is, for delta PL, m by L square into T square, and d power A is L power A, and V power B is L power B by T power B, and rho power C is m power C L power 3C. The exponent for m is converted by 1 plus C is equal to 0. Therefore, value of C is equal to minus 1. The exponent for time is B power is equal to minus 2. The exponent for length is A is equal to minus 1. So, A, B, C are the basic values of the basic components like length, time and mass. We can find C is equal to minus 1, B is equal to minus 2, A is equal to 1. Then also continue. Therefore, the first non-dimensional parameter is phi 1 is equal to delta PL d by rho V square. Similarly, we can get phi 2 is equal to U into rho V D. The new relation is I refer the first non-dimensional parameter of phi 1 is equal to function of phi 2. Delta PL d by rho V square is equal to F of mu by rho Vd, or delta PL is equal to rho V square by d G by Re. How do we know the nature of G? We need to vary the two variables only, which is much easier than the original. We have the certain constant values like delta PL, d by rho and V square, which can see in the previous problem. Then we can find out with a graphical representation. So here we can see the constant distraction of the constant variables, like our constant variables are original values, delta PL d by rho into V square. The Ru value, the nature of gravity value has been increased. We can see in this problem. Like that, we can see the dimensional analysis of the any kind of model can be converted into the structure. The dimensional analysis has been made by using the Buckingham's pi theorem. It is one of the important theorem for the dimensional analysis which can be made. This is also known as stimulate method. Like that has been converted. So in the fluid mechanics, lots of turbines, lots of dams, lots of hydropower plants has been constructed. For constructions, the prototype has been made. The prototype has been converted into the definite structure. So the Buckingham's pi theorems has been used for the analysis and also the dimensional analysis for the prototype, which can be easier to make and construction of an big objects. Okay, that's all about today's episode. Thank you. We can see in the next class.